Greetings, welcome back to this tutorial. In this tutorial, I want to look at this particular type of categorical syllogism where we have a universal and particulars. So this particular syllogism is going to involve shading and drawing X's, and I want to show you how that goes. So if you look here, we have our subject term, D circle, predicate term, A, major term, and our A circle. And again, the term that appears two times in the premises but nowhere in the conclusion, that's our C term. And you can see that this is our C circle. Now, I always tell students when we go about shading your diagram, if you have particulars, a particular claim here, so we have I and O claims, always start with your universals. Always, just as a rule of thumb, start with your universals, and you'll see why in a moment. So let's start with our C and A circle. It says all C are not A. All C are not. And actually, that should be here. All C are A is really what that should say. All C are A. So all C's are in the A category. So here we're going to shade quadrant 4 and 7. And again, we're going to black that out just to show that it's empty. Again, there are no C's that are outside. There are no C's outside of the A circle. Okay, so we've done that. So premise 1 is done. All C's are, which would be 5 and 6, they're all contained in the class of A. Next one says some C are not D. Some C are not D. So we're going to look at the C and D circle, and to say that some C's are not D, we're going to have to put an X somewhere. Now again, for reference, you might have to go back to page 246 in the textbook and show and revisit those Venn shadings and how they correspond with your categorical claims. So we're after an O claim. O claims, we're looking at a C and D circle, and we need to draw X because it's a particular. There's at least one C that's not a D. So we have to draw a C outside the D circle. For the time being, ignore your A circle, and we're going to put our X here. Now the reason we put our X here and not here is because this is empty, right? This is all empty, and so again, that's why I have you do your universal claims first. Do your universal claims first before your particulars, because here shading means empty. If there's nothing there, there cannot be at least one thing there. Okay, so here we have, there's at least one X that's not a D, and that's what we have here. Now, here again is that moment of truth. Let's go to the conclusion, and we're going to set up the conclusion. We have D and A, and it's saying there's at least one D that's not an A. So we're going to go to the D and A circle, and if this syllogism, again, is going to be a valid one, we should be able to look just at the D and A circle and see an X somewhere in this territory. So when we go up here and we look at this territory, we don't see an X. Okay, and that's invalid because this is what we're looking for. We're looking for an X somewhere up here, and we don't see it. Okay. So what we have here is a syllogism where we have a true premise, and a false conclusion, and that's an indication of an invalid syllogism. Valid syllogisms, again, true, true, false, that's invalid. For validity, we need true premises and a true conclusion. Okay, so again, this is how you go about shading and designating your Venn diagrams with X's or shading. Okay, now what I'm going to do next, I'm going to work one more example out. So I'm going to go ahead and pause the slide here, and I'll have another example to work through. Okay, welcome back. So here I have another categorical syllogism. These all have universal claims. An A claim at the top, all A are C. Here, an E claim, no A are F. And then finally here another E claim, no F are C. So again, I'm going to set this up by assigning my terms. My subject term, always the circle to the left. My predicate term, in the conclusion, of course, circle to the right. And then the term appears 2 times in the premises, nowhere in the conclusion is my middle term. So let's start with our A and C circle. A and C, let me number my quadrants. Quadrant 1, 2, 3, 4, 5, 6, and 7. And it says all A's are C's. All A's are C's. So I'm going to have to shade in quadrant 4 and 7 to show that. All A's are C's. Next premise, look at circle A and F, and it says no A's or F's. So what we're going to do is shade in that section where they're overlapping. And now, here again, we're going to just set up here and see if that conclusion is contained in those premises. It says no F's or C's, which means the overlap between the F and C circle should be shaded entirely. But again, when you look at the conclusion, we don't have that. And again, remember, we want to make sure this is represented here, and that's not what we have. Here, if you look at circles F and C, we have a space here where there is something contained, and it shouldn't be. They should be shaded out. It should be shaded out completely. So this argument here, again, is invalid because this here is not contained in these. This conclusion here is not contained in here. The conclusion here, we're going to say this is true, this is true, this is false. So the argument is invalid. The conclusion fails to follow logically from the premises. Or another way of putting it are the premises here, if those are true, they don't satisfy that conclusion. Okay, so that will do it for the shading of diagrams. The next tutorial I'll work with chapter 10, and we'll start working on truth tables where we can expand some of this, but we can expand it with arguments that contain more than 2 premises.